Hi, everyone. In this episode of the On.NET Show, we're going to learn about doing schema design with GraphQL with my good buddy, Michael. So stay tuned and check it out. Hi, everyone. Welcome to another episode of the On.NET Show. My name is Cecil Phillip, and today we're going to be learning about GraphQL schema design from Michael, who's actually the author of a really cool package called Hot Chocolate. Michael, how are you doing?
Hi, guys. I'm great. How are you?
I'm doing really well. So why don't you tell me a little bit about schema design? Like, what exactly do we need to know about schema design, particularly as it relates to creating GraphQL objects with Hot Chocolate?
Yeah, that's a very interesting aspect of GraphQL, because when people start with GraphQL, they start very naively. And most of the times they set up a database and basically try to reflect the database as a GraphQL schema. But that actually doesn't scale very much. So in order to understand GraphQL schema design, what we have to do here is to reflect on what GraphQL is, or how GraphQL tries to solve our problems.
Okay.
GraphQL is a client-centric approach to a service API. And that is important to understand how we use GraphQL and how we want to expose our schema. So let's have a look at Banana Cake Pop and get into the subject.
Okay.
So I'm opening Edge here, and I already have a server running. And let's look at our first query. So I have taken the freedom to take one of the ASP.NET Core examples that C# Fritz has made, and I built a GraphQL server around it. And this is basically the speakers example that he has for ConferenceDB. And what we have here is a simple GraphQL query that fetches a speaker. And we can execute that and get the data like we expect from GraphQL. But if we look, for instance, at the timing, we can see that it costs us 614 milliseconds. So we already know that with GraphQL, I can specify the data that I want, but it goes even further than that. With GraphQL, the consumer is really in the driver's seat. He can also specify which data he or she wants at which specific time. So basically, we could say, okay, maybe sessions is causing our delay here. So let's, for instance, defer the execution of sessions and still use one HTTP stream, but get this piece of information when it's ready. And if we execute that query, we actually get immediately, we get immediately Bill Wagner, and then we get his session when it's ready and the server has resolved that data. So GraphQL really puts us, the consumer of GraphQL API, in the driver's seat. And that's important if you're thinking about GraphQL schema design, because with GraphQL schema design, we aim at a human-readable graph as something that the consumer of the API can reason about.
Right. And I know sometimes when folks are talking about API design, you also hear about like API first design, when people design what the requests and responses are going to look for the APIs. What's the shape of that data that's going to get returned? And so it kind of feels like this is something that you want to do with GraphQL, almost like in the same way you'd want to do database design. Like I design my database and my tables and my containers or whatever the case is, depending on whether you're doing relational or non-relational, to look a certain way based on the querying or the work that I want to do. So I'm guessing GraphQL is a similar situation. Based on the types of queries and the type of work that I want to do, I'm going to have to design my schema to look a certain type of way. Would that be accurate?
Yeah, that's accurate. I actually want this schema to feel natural and basically reflect my business case. If we look, for instance, at this speaker example here, I'm exposing the speaker, and then I can drill into the sessions of this speaker. So it feels very natural when I drill into the data. And again, if I wanted to drill even further, I could drill into the speakers here. Again, it doesn't make sense in this instance, but you basically can drill into your data.
Sure.
But if we look at the code side of this, we actually could see that the speaker data model, which is basically the speaker class that we expose through our entity framework here, actually exposes the session speakers. And that is a collection that represents the relation. But this specific relation we don't want to have. We want this natural way to dig into data. And with Hot Chocolate, there is a fluent API approach, which we didn't see so far, where we, for instance, can provide a special type, a GraphQL type. We basically specifically specify a GraphQL type here and express our intent, how this type shall be reflected in the GraphQL schema. Oh. In this instance, we are, for instance, defining that the session speakers property of our entity type shall be exposed differently. We are not exposing this field directly, but we are using a specific resolver that we defined down here that actually aggregates the data in a way that we want to expose it.
Got it.
And this really lets us clean away those edges that we don't want to have in our graph and makes it clean to use. Okay, then let's head into the next concept here. A lot of the GraphQL schema design principles that we have in GraphQL are designed by Facebook and especially by their client API team. So Facebook has a client API called Relay, and all these design principles were released as Relay server specifications. And one important aspect that maybe was overlooked here is that we have the ID here, and the ID actually is represented as a base 64 encoded string.
Okay.
And that actually is because in GraphQL, we aim to have every object refetchable, meaning we are giving the client the power to just take any ID and refetch the data without knowing what object actually is behind that.
Oh, okay.
And that actually means, if we look at this second example here, for instance, there's a field called the node field, and I can fill in just any ID, and then I can ask, okay, if this ID actually is a speaker, then display me the speaker. And I could say, actually, if this is a session, then I just want the title, for instance.
So tell me, what does that on syntax do exactly?
You could say it's an intelligent switch case in this example.
Okay. It's like pattern matching. Is that
yes?
Something like that?
You could say that. This is called a fragment,
okay.
And it lets me select certain aspects of a type.
Got it. Okay.
And if we fire that, we actually get the same data back. And this is really useful for clients, so they could automatically refetch data without actually needing to know from where in the graph we got this data from. Like if we went back here and maybe got the session IDs, for instance, deeper in the graph here, we don't need to know that we had to fetch first speakers and then sessions. We could directly refetch the data for sessions.
Right. Okay. And so now I kind of want to circle back a little bit to about one of the things that you showed in relation to this, which was resolvers. And
yes.
So I'm guessing with resolvers, is resolvers how we could use different data sources essentially and kind of put them together? So for instance, if I resolve, let's say sessions is in a different database from speakers for whatever reason.
Yeah.
Or maybe something is coming from the cache and something's coming from the database. Is resolvers a way that I could plug those two separate sources together?
Yes. Resolvers essentially I mean, every field that we expose has a resolver. Some are implicit. Like if we look at speaker, all the properties are implicit resolvers. We just infer them.
Oh.
But you can also provide explicit resolvers. Like I could say even, okay, my speaker actually gets a new field, foo, and we have a special resolver here. And then we could plug in a function that fetches from a web service, for instance, data and exposes it through our graph. The graph user wouldn't know essentially where this data comes from. And it's up to the GraphQL how we aggregate it.
Got it. Okay.
Okay. Then there is another aspect in GraphQL, which is the query types. Let me just get the right instance here. And if we look at the schema here, we can see we have a query type. And we have lots of fields here. That's all the root entry points that the server guys basically essentially designed for the consumer to consume data. But it's essentially one type. And if you have large schemas like Facebook with maybe 10,000 types and 300,000 fields, then this will add up quickly. And if you think about exposing that through one C# type, you essentially would have a huge C# class exposing a lot of types, and you couldn't split them up between assemblies. You maybe could do like partial classes, but it doesn't feel good. Yeah. And there is a concept in GraphQL to split types. And we also have translated that to Hot Chocolate. And essentially, if we look at our startup configuration, we can see we have a query root type here, which is just the body of the type, or actually just the name declaration. So we have a query type that is called query. And then we have those type extensions here. And essentially, if we look at one of those, it's a simple C# class again that says that it extends the query root type and brings in some fields. And this really allows me to split up my root types into topic-based query types that are then essentially merged by the GraphQL engine into this query root type again.
Right, got it. So as I'm looking at this right now, for instance, on line 16, I could see line 16, you're using like a DDB context. So I'm guessing you're using Entity Framework. But if I look at some of the other ones, you might be loading them from like different places.
Yes, that's true. Like the idea behind that is that we essentially could split up our GraphQL server in multiple assemblies even, and each of these split up types gathers data from somewhere, and I don't have to put everything into one assembly. So I could split them up and much easier test them. The good thing here is also if you then write tests on them, you could basically just test parts of your graph that you need. Like in this little unit test, I'm just testing the attendee queries here and the attendee mutations. All the other query parts I'm not testing.
Got it. Okay. And then the schema builder you have here would this be in addition to a GraphQL schema file, or is this kind of creating the schema in code?
The schema builder is essentially the way how you create a GraphQL schema in code. Yes, okay. It's the code first way to create a schema. But also, if you had like a schema first approach, you would also need the schema builder to tell it that you essentially want add a GraphQL document and then add the SDL here.
Okay, so then I could extend an existing document, or I could just do everything in code if I wanted to.
Yeah, and you can even mix them. Like you could have parts of your schema in SDL and parts of your schema in code first.
Got it. Okay.
Okay, there is another interesting design approach in GraphQL, and that's about plurals, because GraphQL is actually designed to be very efficient. And that means that we always want to expose each field to fetch plurals. What does that mean? So essentially, I could ask for a speaker, for one speaker, like we did here, and then we fetch that. But often I want to also be able to fetch maybe 2 speakers. So that's why we should always expose a second field, in this instance, speakers by ID, that fetches 2 or more IDs. So why is that? Because an actual GraphQL query would use variables, and it would allow the GraphQL client to just pass in an array of IDs. The rest of the query could be compiled by the server, and also the server could then optimize maybe the data fetches to just have one fetch on the database. And essentially, if we look at the implementation for such a thing, we go to our attendee queries, and we can see that we have one get attendee by ID, and we have basically the plurals get attendees by ID. Okay. Then let's head to the next point, and that's essentially the last point I want to make today about schema design. There are lots more things that you can actually talk about in schema design, but if you stick to just a couple of rules, like designing in plurals, be specific about what the a resolver does, what a field does, and also do mutations right, then you get very far with your schema. I see that people often struggle just with these simple things, because if they look at the graph, essentially, they often don't look from the types perspective, but from the graph perspective. And that is especially a problem with mutations. Because if we look at mutations, people tend to want to nest them. Like they want to create here a mutation that maybe is called session. And then under session, they want to add something like add, like sessions add. So they try to build a logical function graph, but that doesn't work with GraphQL. Actually, just the top level here is the mutation. Everything beneath here is a query. And that is basically because this piece is performing the side effect, changing the data. And this allows us, so the next level allows us to query the changed state of the server.
Oh.
If we yeah, that's the first thing people really struggle with. And so essentially, if you want to structure your mutations, again, split them like we did with the queries. But this is our mutation. If we fire that up, we can see essentially we added a session here, and then we reselect the data. For instance, we want to grab the generated IDs here, and got the changed state of our server. And the second aspect here is be specific about your mutations. Don't create mutations like a modify session and then do wild patching logic there. Be specific about your business cases here. And for instance, if we add a session to a conference debate, it's maybe when the speaker files a talk. And then we might have another mutation that internally maybe works on the same table that schedules the session for a track, for instance. And if we fire that up, we in this instance get the error because we didn't grab the ID here. And we file that. And then here's another interesting aspect about that. You should also, when you do mutations, design into your payload types of the mutation the user-defined errors.
Oh.
In order, so the client really has also in the schema designed the error structures. So in this instance, the server tells me that the end time should be after the begin time of the talk. So we could make it a 1-day talk. Fire it again, and now my session is scheduled.
So quick question about that part of it. When there's errors in GraphQL, at least in that particular instance, I noticed you're still returning, or the server is still returning a 2000 OK, even though there was an error in the payload. So does GraphQL not really use status codes as much to denote errors, or just purely rely on the body of the payload?
No, it's actually there is a specification, the GraphQL over HTTP specification, and that says that if data is null, so if this part becomes null, then it's a 500. And that is because GraphQL can also deliver partial results. Let's say we not only have this, but maybe we have multiples. We have this, and we could also add a second one.
Like B or C or something.
Yeah. Then we add 2 sessions. One will successfully be added to the server. The second one fails maybe. Then I would still have a valid partial result for my client. It's just not everything okay. So I could maybe live with that, sort out the errors, and then say, okay, I have added one, the other one failed. Or if you think about trading applications, maybe I cannot get the share prices from one provider, but from the other. So GraphQL is about efficiency. Take the partial data and then deal with the errors, maybe refetch the other part.
So that's almost like talking about batching. So I want to do multiple things at the same time. I could batch those requests, so I could batch those requests over at the same time. And then GraphQL will let me know, okay, well, this is finished and this is not finished, or, this is what's left to be done kind of thing.
Yeah, kind of. There's also a specific GraphQL batching, but you could say so. You always try to do everything in one call, and then maybe defer parts of the calls, like I showed initially, like this part I need now, this part I need later. And you basically sort it then out through the errors. But in this error case here, the error is really designed into my data logic, right? Like if I look in my schema, like if I look at the schedule session, I really can see there is a user-defined error here. So this error would always be 200 because it's just an object that I return where I tell the user this is my domain error.
Got it. So I'm guessing that we could just reserve HTTP level status codes for machine level and framework level errors, but from business errors, then it will be a user-defined error that would come in the payload, and we'll still get a status 200 OK from the HTTP request.
Yeah, like if I would send in an invalid query, like the syntax is wrong, then I would get essentially a 400 because the request is not parsable for the server and stuff like that would be with error codes.
Got it. All right. Well, hey, Michael, this has been great, man. Like, I feel like every time you come on the show, you show us so much good information. If folks really want to learn a little bit more about GraphQL schema stitching and doing some schema design and some of those types of things, can they head over to the Hot Chocolate docs to learn about it? Or where would you recommend folks go to learn a little bit more about how to really do schema design really well?
We have a great GraphQL workshop. That's basically what I showed bits and pieces out. And this really goes into some of the aspects again, a lot more than I showed here on the show now. And you really can do this workshop, and then after that you will gain a lot of knowledge about how to apply schema design to your project.
Got it. So I could do this workshop and I could become a hot chocolate expert. I can make the best hot chocolate in the world after I do that.
Yes, you could.
Awesome. Well, hey, Michael, thank you so much for coming on the show. I really appreciate it. And thank you all for watching. This has been another episode of the On.NET Show, where we learned how to do schema design with GraphQL.